Okay, we are going to work on changing from a a rectangular equation to a polar equation. Now, rectangular equations are those that include x and y that we typically graph on our Cartesian coordinate plane with an x and a y axis. Polar equations are those that have sines, cosines, and r's, and we typically graph those on a polar graph. Here are our tools, our basic tools that we use, and there may be some tricks that we use as we go along as we're converting these. But remember that x is equal to r cosine theta, y is equal to r sine theta, and r squared equals x squared plus y squared. Okay. So what you would want to do is just take a look at the equation, replace any x's and y's with something they're equivalent to, and remember, we do know that x is r cosine theta, or yes, r cosine theta. So right there we can replace the x with an r cosine theta. Our y we can replace with an r sine theta. And depending on who you're working with, what text you're working out of, these will be simplified in different ways and end up looking different ways. But we want to simplify if we can. I would probably move the r sine theta to the other side so that I have my r's on the same side at least. So now I have 3r cosine theta plus 4r sine theta equals 5. I can factor out an r, so then I would have 3 cosine theta. We want to make it look as simplified as we can. Like I said, there's not really a standard. It depends on your text. So this is one way we could leave it. We have converted it because there are no longer x's and y's. Everything is in terms of trigonometric functions and r. You may go one step further on this one. Some people would go ahead and solve for r here. Divide both sides by 3 cosine theta plus 4 sine theta. I would accept the answer this way. I would also accept it if you went ahead and divided. Okay, so the two acceptable ways that I would take as your answer here. All right, here's one. It looks pretty straightforward. It's just x equals 5. We want to change that to polar form. So we would do our substitutions. We know that x is equivalent to r cosine theta. So I can replace my x with an r cosine theta. And that's equal to 5. We want to simplify that if we can, so let's solve for r. To do that, I would divide both sides by cosine theta. So I get r is equal to 5 over cosine theta, and I could probably go one more step. We know that 1 over cosine theta is secant theta. So 5 over cosine theta is 5 secant theta, and that would probably be the best form to leave our answer in. We substituted for our values so that we no longer had x's and y's, and then I solved that for r. All right, here's another y equals 4. So again, we do our substitution. We know that y is r sine theta, so I have r sine theta equals 4. Okay, again, if I solve for r, I would want to divide both sides by sine theta. And that gives me that r is equal to 4 over the sine of theta. Okay, the same as we did on the previous one, we know that 1 over sine theta is equal to cosecant theta. So let's just replace that, and we get r is 4 times cosecant theta. Okay, so some of them are pretty straightforward. Some require a little more work and a few tricks. So here we have x squared plus y squared equals 36, which is the graph of a circle with radius 6 and center at 0, 0. We want to convert that to polar form. So we take a look, and we know that x is r sine theta, or x is cosine theta, and y is r sine theta. But notice here we have an x squared and a y squared. You can still substitute those in as r squared cosine squared theta and r squared sine squared theta. But if you have x squared plus y squared, we know that x squared plus y squared is equal to r squared. So rather than write these out, factor, use an identity, I'm just going to substitute straight in x squared plus y squared is equal to r squared. So I substitute right there. And I have that equal to 36. Now I probably want to go ahead and solve this for r. I would do that by taking the square root of both sides. And when you take the square root, remember you're supposed to do plus or minus, and then we just kind of think about what we have here. R equals plus or minus 6. Well, remember on a polar graph, R equals 6 would just mean that any angle, I could have any angle, just a radius of 6, so I'm 6 away from the center. Okay, so having R be positive 6 and R being negative 6 is really going to give me the same graph, because negative 6 just means I go 6 in the opposite direction, which would give me actually both halves of the circle. So we can write this as just R equals 6, because remember when you get an angle, the positive and negative just takes you the other direction, but when you do the angles all the way around the circle, you end up getting the entire circle anyhow. All right, here's another. X squared minus 2y plus y squared equals 0. So we could go ahead and substitute our r cosine theta or r sine theta. Anytime you have x squared plus y squared, it's faster to just write r squared rather than substitute and simplify. And notice here, if I rearrange this, I do have an x squared and a plus y squared. So I'm just going to rearrange this a little and then make my substitutions. I know that this is the same as r squared. I know that y is r sine theta, so I have minus 2r sine theta equals 0. Okay, from there we might want to solve a little bit. So you could either factor out an r, but probably what I would do is add 2r sine theta to both sides. Okay, that gives me r squared equals 2r sine theta. Okay, I have an r in each one. If I divide by r here, that leaves me with r equals 2 sine theta, which is probably as simplified as I'm going to be able to get that. All right, next one, y equals the square root of 3x, and I apologize for let me rewrite that question. That's not how I intended it to look. I meant for it to look like this, y equals the square root of 3 times x up here. I didn't want the x under the radical. Okay, so notice we have our y and we have our x. We can go ahead and substitute here. If we do, we get r sine theta equals the square root of 3 times r cosine theta. Now that doesn't look very nice. I have r's here and here. So let's get our r's on the same side. I have the square root of 3 times r cosine theta. So I'm going to divide by r cosine theta on both sides to move that over. And then I have r sine theta over r cosine theta is equal to the square root of 3. Well, notice I have an r divided by an r, so my r's are gone. Now I have just sine theta over cosine theta equals the square root of 3. Okay, if I continue from there, what is sine theta over cosine theta? That is just tangent theta. Okay, and how can I finish this out? I either want to have r equal to something or theta. Notice my r's, they are no longer here. So instead, when your r's are gone, you want to try and solve for theta so that you have an equation with theta in it. How would I solve for theta? Well, I have the tangent here. To get rid of that, I would need to do the inverse tangent or arctangent. So I'm going to do inverse tangent of both sides. Here I get theta, and if I take the inverse tangent of the square root of 3, where is tangent equal to root 3? Well, that happens at pi over 3. Okay, happens here. It also happens the same place in the third quadrant. But notice again, on a polar graph, since my radius can take me here and here, theta being equal to pi over 3 would actually give me the same answer as theta being equal to this, the angle down here in the third quadrant. So I can just write my one answer, theta equals pi over 3. Again, the reason for that is, remember, we repeat values. The only thing that changes is if your r is positive or negative.